Hi, today's lesson's on the zeros of polynomial functions. Our first thing we're going to do is we're going to use the zeros to graph a polynomial. So we're going to use this and we're going to use our knowledge of end behavior to go ahead and graph this. So to find the zeros, we just do the opposite of these or whatever. So if you take a look at this, the 0, since x is by itself, is 0. The opposite of negative 4 is positive 4. Opposite of positive 3 is negative 3. That is where it crosses the x-axis. And be careful with this graph, it's all done by 2's. So we have one at 0, we have one at 4, we have one at negative 3. Now, if we take a look at all the x's, there are 3 x's, which means it has a degree of 3. And in front is positive, so our leading coefficient is positive. So since it's positive odd from a chart I made earlier, it goes low and high. So we're going to start low here. We're going to curve up, curve down, and back up. And that's how you can use zeros to graph a polynomial. Go ahead and try this problem. Okay, so sometimes we'll have multiple zeros. What a multiple zero is basically where it crosses the x-axis in a certain way. It's either going to bounce off or it's going to go through in a curve. So let me show you what I'm talking about. So if I have like x minus 2, x minus 2, x minus 2, we only have one zero, which is 2. But we have 3 multiples of it. So we say this has 2 mult 3. In other words, it's a 0 or root of 2 if that is happening 3 times. So if we take a look at the graph of this, it would cut through the graph in like kind of an S curve kind of thing. So that's basically how it works. What if you have something like this where it's x minus 2 squared and then x minus 1? So something like this, you would say it is 2 mult 2 and 1. Since there's only one of it, that's it. So once again, the graph of this one, if you were going to take a look at it, would be at 1 and at 2. Well, 1, it would just cross over, and then 2, it would bounce off of, like that. Because whenever it's got an even multiplier, it just bounces off like a parabola. Go ahead and try this problem. Okay, to find real and complex zeros or roots, whatever you want to call them, we have to use a lot of synthetic division, quadratic formula, everything. So if you don't remember the quadratic formula, it's negative b plus or minus square root of b squared minus 4ac all over 2a. So we're going to use that. But in order to use that, we need to get down to 3 numbers. So what we're going to do is we're going to use the graph to help kind of cheat this a little bit. So if you notice, we do have a root shown, which is right here at 2. So we're going to do synthetic division, but with a 2. So after setting up synthetic division, all we got to do is solve it real fast. So 2, 3, 6, 3, 6, 0. And it should be 0 here because it is a root. It crosses the x-axis. So we know for a fact that's got a remainder of 0. Now, since we're down to 3 numbers here, this is our A, our B, and our C, and we can use this with the quadratic formula. So I get negative 3 plus or minus 3 squared minus 4 times 1 times 3 all over 2 times 1. Now if I plug this in, solving like normal, I get negative 3 plus or minus 2. This under here is negative 3. Since it's negative 3, we know it's going to be I square root of 3. And now we're done. So these are our roots for this one, but we have one more root we already have, which is 2. So we just list them out like this. And that's it. So if you're given a root, do synthetic division and then quadratic formula to find the rest of them. Go ahead and try this problem. Try this problem.